Hello, today's lesson is on linear functions. Linear functions and graphing of linear functions. So before going to the linear functions, let us just quickly check that what is the definition for function. So the definition of function is given as a function y equals to fx is an algebraic expression that will generate only one value of y for any one value of x. So what does it imply? It implies that if x takes 4, then y can only take 2, 3 or any one value. It cannot take a set of values. So simply if we look at the Cartesian plane, then any curve, it can be said it is function because for every corresponding value of x, it has only one value. So what we are seeing that if you draw the vertical lines on this curve, the vertical lines only meets with this curve once. So any curve you can draw over here, any loop kind of thing or even a circle. If you simply test it like this vertical line, we can see the function is intersecting with this vertical line at 2 points. It means that every corresponding value of x, there is 2 values of y. So then this kind of curve cannot be considered as functions. So as our topic is linear functions, then we need to check that what is the form of the linear function. The form of linear functions. It is y, we can say that y or even fx equals to mx plus c, where m is the slope of the line and c is y-intercept. As it is linear function, then it should be a straight line. Yes, in function, straight line is considered also as a curve. So it should be a straight line. So if this is fx or even we say it y, then this angle it is creating with the x-axis is called the slope of the line. So what it is simply the tangent value of this theta is the slope of the line, or this vertical distance by this horizontal distance from the origin is given a slope of this line, and we can write it as m. So simply m equals to y by x. This y means this vertical distance and this x means this horizontal distance. Now we need to check that a line can be inclined in any way, right inclination, or even the line can be inclined left-handedly, or this line can be parallel to my x-axis as well. Let us see this situation first. Now, as we already discussed, that there is 3 possibilities when we graphed these linear functions. Now let us see it in details. This is x-axis, this is y-axis. So there is a possibility like the line is inclined on the right hand, means this is the theta it is making with the x-axis, and this is called the slope. All these lines, those are inclined on the right hand side with any angle. This is theta 1, this is theta 2, or even this one, theta 3. So if the angle is acute angle, it creating an acute angle with the x-axis, then we have seen that m, the slope of the line, is always greater than 0, and this we consider as our case 1. Second one, when the line is inclined on the left hand side. This is my x-axis, this is my y-axis. So whichever way the line is inclined, and if it is left hand side inclination, the angle created with x-axis is this, and in this case always m is less than 0. And the third case, where we found that m equals to 0, those are the linear functions or the lines that are parallel to our x-axis. So this is y equals to say a, and this is y equals to say b, and if this is, you can say y equals to minus c. So all are parallel to the x-axis. So we have three cases over here when we are graphing a linear function. Now it may ask to sketch a line like this way, that y equals to 3 minus half x. To sketch a line, we at least require 2 points. Then we draw a line very easily. So to find these 2 points, what we consider first, that x equals to 0 to find out the y-intercept. So if in this case, if we take that x equals to 0, we find that y equals to 3. So y is cutting at this point of this line, the y-intercept we are getting. Now for having this x-intercept, that x-axis intercept, we have to consider that y equals to 0. So when it is y equals to 0, we are having that x is just interchanging is 6. So we consider that 3, 4, 5, 6, yeah. This point over here, it is 6 and this is 3, and these two coordinates 6, 0 and 0, 3. And we simply trace the line like this way. So finding these 2 points, we can trace any linear curve on a Cartesian plane. Now let us see the properties of a straight line. The properties of a straight line. As we discussed earlier, what we call slope or inclination, that is called the gradient of a line. And the gradient of a line is denoted with m. So how to find out this gradient? The gradient of a line can be found by the distance of two coordinates, or difference, sorry, not the distance, actually the difference of the two coordinates. Suppose a line is going like this way, then if you find that this coordinate and this coordinate, say for sake of this is x2 y2 and this is x1 y1, then gradient will be found like y2m equals to y2 minus y1 divided by x2 minus x1. And for the thumb rule, whichever be the right hand side coordinate, it always taken as x2 y2, and the left hand side coordinate always taken as x1 y1. Even the inclination is like that way in the left handed side inclination, then if we consider this and this point, then this right hand side point will consider as x2 and y2, and this left hand side coordinate will consider as x1 y1 to find out the gradient. This is say about L1 and this is L2. This also helps us to find out the equation of a line. Suppose if says that a fixed point is there on a line is called x1 and y1, and it has given the gradient of the line is m, then from this equation we can find out what would be the form of that straight line. Okay, we can find out the straight line equation from these two knowns. Then we consider that y2 as simply y. We will write that m equals to y minus y1 by x by minus x1, and by cross multiplication that y minus y1 equals to m into x minus x1, we can easily find out the equation of the desired straight line. Now the second properties is called the parallel lines. So a straight line L1 can be parallel to L2 only when the gradient would be same for those two lines, like that m1 equals to m2. It tells us that if this is my axis x and y, it means that when two lines are parallel, or they can only be parallel when these two angles are absolutely same. They will make the same angle with the x axis. It means the gradients are same. So this is my second property of a straight line. And then what is the third properties? It is coming for the perpendiculars. Sometimes bisects, a line bisects another bisects. It means that they are intersecting with them with 90-degree angle, like my axis itself. So when two line intersects at right angle, sorry, let me check the right angle. At 90 degree, suppose this is L1 and this is L2. In this case we said that L1 is perpendicular to L2, and we saw that the gradient, the multiplication of the gradient of these two will produce minus 1. So the product of the two gradient will be minus 1, or we can say m1 equals to minus 1 by m2. If this situation arises, we can easily say that two lines are perpendicular to each other. Now, we can ask to trace this kind of function on a Cartesian plane. The same thing for tracing, we require just 2 points for a linear function. So, we have to first find the y-intercept and then the x-intercept. So, for y-intercept, we will take that x equals to 0. So, when x equals to 0, we have that fx equals to 3. That means the coordinate of that point would be 0 and 3. Similarly, to find the x-intercept, we will consider that fx equals to 0 and putting the same value, we are having x plus 0 equals to 3, hence x equals to 3. Therefore, the coordinate of that point would be 3, 0. Now, we can easily plot it on our axis and trace the linear function very easily. So, this is my 1, 2, 3, 3, 0 and this is my 1, 2, 3, 0, 3. So, from this 2 point, I can easily draw the line that I have to ask to draw. Again, sometimes we have to find out the gradient of a line. Like this way, the example is find the gradient of the line joining the points 3, 2 and 5, 6. Okay. Now, we can see that 5, 6 is my right hand side points and then 3, 2. So, I will consider these 5, 6 as my x2, y2, and this is my x1, y1. And applying that m equals to y2 minus y1 by x2 minus x1 and placing the value over there, I am having 6 minus 2, 5 minus 3, this is 2 by 2 equals to 1. So, the gradient of that line is 1, that passing through these 2 points 3, 2 and 5, 6. Now, again, we may ask to find the gradient of the line A that is perpendicular to line B with a gradient of minus 5. Okay, so we know that from the properties that m1 into m2 equals to minus 1. Now, suppose line A is m1, so I am keeping m1 over here equals to minus 1 by minus 5. I am getting the gradient of my line A is 1 by 5. Like that way, many problems may ask to you, you have to answer by using the properties of the straight line. Now, take up this example as it has given. A straight line passes through a point 4, 3 and is perpendicular to the line joining the points minus 1, 3 and 1, minus 1. Find the equation of the line. So, it is perpendicular to this line that is joining these 2 points. So, we are not finding out the line, but we can find out the m from these 2 points. Now, we can see from the value of x that this is my right hand side coordinate and this is my left hand side coordinate. So, yes, hence this I will consider it my x2, y2 and this is my x1, y1. And then I find out the gradient of the line, of this line that joining these 2 points. It is, yes, minus 1, this minus 3 and this 1, then minus 1, so it's a plus 1. So it is coming as minus 4 by 2 is minus 2. Now we know that when two are perpendicular lines, then their product of the gradients will give me -1. Using this property, I am placing this, that m1 equals to -1 by -2, that is half. So, and again this straight line is passing 4, 3. I am writing first in form of a linear equation, that half x plus c. So, this c intercept I will find it out by replacing these 2 points over here. So, what I am doing it, the 3 equals to half 4 plus c 2. So, c equals to 1. So, my line, desired line, that is asked for, will have take this form, and simplify this, or multiplying both sides with 2, I am getting 2y x plus 2. This is the line is asked for. Now, sometimes we may ask to trace this kind of lines also. Now, what we can see, that as a greater than 0, a by a plus 1 is a positive quantity, and a by a plus 1 is less than 1. Of course, a plus 1 would be greater than a. Hence, this is a pure fraction. Why I am considering this thing? Because I know that the angle theta, if it is 45 degree, if theta equals to 45 degree, then what is my gradient we are calling? It is my, that is the tangent of theta of that line, and tan 45 degree equals to 1. So, when it is less than 1, so my angle that the line is making with the x-axis must be less than 45 degree. Because of that reason, so I am making an acute angle that is less than 45 degree, and it's arbitrarily. It's a gap. Yeah. Yes. So, this is my line, and how I can represent this line is that this would be my y-intercept. So, this is my minus a distance. So, this coordinate would be 0 minus a, and this coordinate would be my a plus 1 0. So, this is my desired line. So, why again I am just taking that this a by a plus 1 is my gradient. So, by using these two coordinate I am getting the same gradient. Let's see. Yeah. So, y2 is 0 minus y1 is minus a, so plus a, by x2 is a plus 1 minus x1 is 0, this, so it is a by a plus 1. M equals to, yes, this is my desired line. So, I have to always mention these two coordinates when I am tracing this kind of graph, where a is any arbitrary constant and c x is minus a, so my y-intercept it is minus a. Now, let us see the solution of the equations, that is simultaneous linear equation into unknowns. So, a pair of simultaneous equation in two unknowns may be solved in two ways, either algebraically or graphically. To solve means to find where these two straight lines intersect. When we give the solution of two simultaneous equation, it means that both the lines are intersecting. That is also a meaning, the graphical representation of finding the solutions of two simultaneous equation or two straight lines. That where the point or the coordinate, the two curves meet, we can give, that is the solution. If they are not meeting, means if the lines are parallel, they cannot meet at any point or they cannot intersect, then we don't have the solution of that kind of pair of equations. Now, let us take an example of this thing, that x minus 2y equals to minus 7 and 2x plus 3y equals to 0. Now for this graphically, in the same set of Cartesian plane, we have to graph both the equations. So sketch both the line on the same set of axes. So what we are finding for this first one, and this I am already mentioning the second one, yeah. For the first one, for the y-intercept, to find out the y-intercept, the value of y, I am placing it x equals to 0. So I am having that y is 7 by 2 means 3.5. So I already trace it over here. And for the x-intercept, I am putting y equals to 0 and finding that x equals to minus 7. So these 2 points joining and extending on the both sides, I am having this line. That is my first equation. And for the second one, see, the second one is a little tricky. For x and y is passing through the origin. So what I am doing, I am also taking it like that way, that 2x plus 3y equals to 0, that is passing through origin. I can see it that x 0, y is also 0, y 0, x is also 0. So they are passing through the origin coordinate. So I am creating this kind of relation like this way and taking that x equals to 3. So I don't have any denominator. I am finding that y equals to minus 2. So this line is also passing through 3 minus 2, the coordinate. I already trace it up, and let me draw these two lines. So this is their point of intersection. Let me check the coordinate of this point P. This is my 2. So it is my minus 3 plus 2. So minus 3 and 2 is the coordinate of this point of intersection. So I can give the solution for these two lines graphically is x equals to minus 3, y equals to 2. Now see it algebraically. Generally in algebra, we have two methods to find the solution of this pair of equation. One method we call it elimination. Another method we call it substitution. In elimination, we have to take some numbers that will make our this x multiplying one equation with that and making the coefficient of a particular. Suppose in this one equation number 1, if you multiply with 2, we are making the coefficient of x same with the coefficient of the next equation second x. Now if I subtract this thing, I will find that x is eliminating and I am directly finding the value of y. So doing the same thing for the elimination method, multiplying 1 with 2, I am having a third equation, 2x minus 4y equals to minus 14, and I am marking it as my third equation. Now I am 3 minus 2. So what I am doing, I am writing first my third equation and subtracting the second equation from this. So minus 2x minus 3y equals to 0. Now by doing it so, I am already eliminating this 2x. So I am having minus 7y equals to minus 14. So y equals to 2. Yeah, graphically we also find that y equals to 2. Now I am putting this value of y equals to 2 in my 1. What I am having, x minus 2 into 2 equals to minus 7. So x equals to minus 3. So that is also the solution. And now see the substitution method. In substitution method, I am simply substituting a value of one into the another. So let me write the pair of equation first. Now what I am doing over here, I am finding that is 1, this is my 2, and I am using this substitution method for the solution. That from 1 I am getting x minus 2y, so x equals to 2y minus 7. I am simply placing this value over here in my equation 2. So substituting the value of x. So this method is called substitution method. So what I am doing, 2 into this 2y minus 7 plus 3y equals to 0. Now 4y minus 7 plus 14. So 3y equals to 0. So 7y equals to 14, or y equals to 2. Then again replacing this value over here. What I am getting, x equals to 2 into 2 minus 7 equals to minus 3. Yes, so this is the method I can adapt to give the solution of the simultaneous equations. When the simultaneous equations I will find with x, y and z, I will do the same procedure. By substitution and elimination, both will be used simultaneously to find this kind of 3 unknowns. So there is 3 straight lines. Now it comes as a third dimension. Let us check that how that third dimension, or the third way I am writing that this is 2-dimensional. Now this 2-dimension, if I place it like this way and putting a vertical axis to that x-axis, so this is my x and y. Now it is my, this is my x, this is my y, and this is my z-axis. So this way I can also find out the solution for 3 simultaneous equation of 3 unknowns that deals with 3 variables x, y and z. Now the simultaneous linear equation in 3 unknowns. So similarly the 3 unknowns, we can create this kind of equation where a, b, c all are real constant or real values, real numbers. So this way we can represent a simultaneous linear equation in 3 unknowns. Then we know that if 2 unknowns it is there, we have plotted it on the Cartesian plane and we found that it is a straight line. Then how this kind of equation looks like? It is actually this 3 axes, x, y and z axis. If we say that this is x, this is y and this is z axis, then we will find this equation form a 2-dimensional plane of in this kind of 3 axis. This forms a 2-dimensional plane. So to solve this kind of linear equation, as 3 is unknown, we also require 3 equations like that way. So that gives the 3 planes, those are interacting in this 3-dimensional x, y, z axes. So how they are interacting? This is a photo I have taken it from IBDP Publishers book, a 4th edition. Editor is Fabio Citrio. It says that these 3 planes, 2-dimensional planes, when interacting in a single point, we will say that 3 equations has a unique solution. They all are perpendicular to each other to meet in a single point. Then we will find that x equals 2, y 3, z equals to -2, this kind of solution. Apart from that, these planes can be interact or may not be intersect at all. Okay, this plane, 3 plane can be parallel, then 2 planes coincide and one is parallel to them, and all 3 planes coincides, or any line of intersection is parallel to the other two. These 2 planes are intersecting and one plane is just intersecting with them at a distance. So these 2 lines are parallel. Again, these 2 lines are parallel. These are parallel, and these 2 lines are again parallel to each other. So they are intersecting in 3 straight lines. Again, 2 parallel coincident planes crossed by the third plane. So we are having 2 parallel lines. So 2 parallel coincident planes crossed by the third plane, we get a single line. Or all 3 planes intersect along a straight line this way. All 3 planes intersect at a unique point. When all 3 planes, you see in this kind of thing, they are just perpendicular to each other. All the planes are perpendicular to each other, then they are intersecting with one unique point. Then we have a one unique solution for these 3 unknowns. I hope this explains these linear functions to you very well. Keep on practicing, and if you have any queries, any questions, please leave a comment. Thank you.